Hello guys, this is Michael. Today I'm going to introduce you how to install and use PyExplainer. Actually, the easiest way is just click this launch binder badge and then the remote server would start because this repository is hosted by binder, and we start the server and you can run the notebook on the server side, so you don't have to use it locally. See, but you would have limited performance because the memory is just 2 gigabytes, but I think it's enough. Okay, so if you want to install it locally, you can just download the zip file and unzip it wherever you want. After that, you just cd to the main folder and then you can call pip install dot. So the pip would manage the installation for you because we have set up the py. So after installation, you can just open the folder wherever, on whatever IDE you have, like VS Code or PyCharm. In my case, I use Jupyter. So you just find the tutorial file and open it. Yeah, I'll just skip the description here. You can read it by yourself. And the first part, quick start, it's about the quick demo. So I'll just run through all of the cell here and then explain them. Okay, so the first is just import the required library, and the second is get the default data and model, and those data and model are just for demonstration usage. And after that, we create our rule, and then we visualize the rule, and you can see the visualization here, and you can play around with the slider here. This slider means you change the value of feature, and then the model generate new prediction for after changing that feature. You can just change it and you see the risk score increase because we move the value to the red zone. Yeah, you can just play around with it. And if you have trouble displaying this widget, I mean the slider or even the visualization, you just run this cell here, which enable your notebook extension, like enable the widgets. It's mandatory for our task. So the part B is about the full tutorial, like the full workflow of PyExplainer, and I will walk you through this part B and explain step by step. So the first one is we prepare our sample data and model. So for preparing data, I'll just load the sample data from the library. And we see here we have 7 columns, and I just show 3 rows. Actually, there are more. After, you can load your data, definitely. And after that, we define our index column. In our case, you can see here, our index column is file name. So file name is our index, which means this file, I want to predict this file if this file is buggy or non-buggy. So that's what our model do. And you can define your own index in your case, and or you don't want to define it, it's fine. If you don't define it, Panda would define index row as counted from 0. So it's totally fine. After that, we define our feature and label columns like this. So X is our feature and Y is our label. So the last column is label, and whatever before the last column, we define it as feature columns. And then you can see here we apply feature selection function, auto spearman, to reduce the number of feature. If you are interested in this auto spearman algorithm, you can refer to the paper link here. Just click it. So after we define the feature and the label column, we'll just split the data into training and testing set. 70% training and 30% testing. And after that, we define our model and fit our model. You can see this is really fast because this model is not that big. And after we have our model, we need to generate the prediction to predict each file if that file is bugged or not. So the predicted bug false, false, false here. Okay, this false means our model predict this file as non-buggy file. All right. So after we have prediction, we'll just we need to do some prediction post-processing. Okay, you'll get what I mean. So here we combine the feature column, label column, and the predicted column. So the reason why we need to do this is because if we only have prediction, we cannot generate explanation. We need context, and that context means the features. So we need to combine the feature with the generated prediction. So here is what we do, and after that, we filter out wrongly predicted rows since we're not interested to like explain the prediction that is wrong. All right, so okay, as we can see, the model correctly predicted 90% of testing data, which is acceptable. And after we filter out wrongly predicted rows, we need to focus on bug file. Therefore, we filter out non-buggy file. So here, the real bug need to be true. All right, and we are good to go. So here we have all of the prediction which are correctly predicted, and all of the prediction are buggy, means all of those files are predicted as buggy. And then we define our feature columns and label columns, which means remember before we combine the feature and label for the prediction. So at this stage we separate them again, which is for later usage. Okay, so after we separate the feature and label, we select one row of correctly predicted bug to be explained. Okay, so imagine you have multiple files that are predicted as bug. You just choose the one you are interested in to explain why the model predicted as bug to explain. All right, so here in our case, I just choose the index 0 for simplicity. So after we define our row, we can see the x-explain is just that row of feature, and the y-explain is just that one row of label. So x, y explain, which just means one row of data. And after that, we create rules. Rules is kind of explanation. You will know what I mean later. So first we need to initialize a PyExplainer object. So in this case, we need to pass xtrend, ytrend, and independence variables, dependence variables, and global random forest model that we trained before to the PyExplainer object. So it's just give the context to PyExplainer to tell it what is our global context. So after that, we need to create rules by triggering explain function. So which is really easy. We just call the PyExplainer and then explain, and then we pass the x-explain and y-explain. Remember, this is just one selected row of data that we want to explain. So we pass them into PyExplainer explain function, and we get the rules. This is a bit time consuming because of the because PyExplainer will consider there's a local model, and it's kind of there are a lot of computing for a local model, so that's why. Yeah. Okay, so rules dot keys. This shows because these rows are just is simply just a dictionary. So rules dot keys just tell us what's inside the dictionary. So if you're interested in those what's in those keys, you can just refer to appendix here, which we introduce the rule object in detail. Okay, the last step is to visualize our generated rules by just calling the PyExplainer object .visualize and pass your rules, and we get our rules, and you can play around with the slider. Done. Okay. Oh, good then. I think this is all for today. I didn't mention too much about the technical detail of how PyExplainer backend works, how the local model works, or what's the architecture of PyExplainer. If you are really interested about how PyExplainer work, you can refer to the paper, which is inside the repository man folder here, PyExplainer paper.pdf. You just click it, and why there is nothing? Wait. Hold on. Oh, good job. Okay, you just download it, and yeah, there's a lot you can read. And all right, see you guys later. Thanks for watching.